Today we will discuss about the non-existence of electron inside a nucleus by using uncertainty principle. So first we will discuss what the uncertainty principles. The uncertainty principle says that the uncertainty in the position and the corresponding momentum, the uncertainty in the corresponding momentum, if you make the multiply these two quantities, it is always be greater than the h cross by 2. Okay, where h cross is actually h by 2 pi and h is Planck's constant. And it has a value 6.62 into 10 to the power minus 34 joule into second. Okay, we can prove this. The electron cannot stay inside a nucleus by using uncertainty principle. For that, you just assume that let the electron stay inside the nucleus. Suppose this is a nucleus. This is a supposed nucleus, and electron is staying inside the nucleus. Suppose this is the diameter of nucleus, and the electron is staying anywhere in the nucleus. So that means the electron can stay anywhere in between these two lines. So in the diameter, anywhere at the any point of the diameter. So the nuclear diameter is order of actually 10 to the power minus 14 meter. So that means the uncertainty in the position of the electrons, the electron can stay here, 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 anywhere in between these 2 points. So this is actually 10 to the power minus 14 meter. So the uncertainty in the position of electron will be 10 to the power minus 14 meter, because electron can stay anywhere in the diameter of the nucleus. So its uncertainty in the position will be the order of 10 in diameter of the nucleus. Okay, now we can calculate the similarly. This is the maximum uncertainty. This is the maximum uncertainty in the position of the electron inside the nucleus. Okay, now we know that delta x and delta px, if you multiply these two quantity, will be greater than equal to h cross by 2. Okay, now you take the lower limit of this equation, the lower bound, that means delta px is equal to h cross by 2, and delta px will be, or you can write it as simply p, and delta x as x will be equal to h by 2 pi multiplied with x. Okay, now simply if you calculate this equation, then h is actually 6.62 into 10 to the power minus 34 joule into second, and 2, there will be a, so this will be 4 pi actually, 2 here is 2, it will be 4 pi actually. So 4 multiplied with pi is 1.141 multiplied with x. X means the uncertainty in the position measurement, which is the order of 10 to the power minus 14 meter. Okay, if you simplify this expression became 6.62 into 10 to the power, I have taken this 10 to the power minus 14 to the upside, then it will become minus 20, and it is 4 into 3.141, it will be 4, 6, 5, okay, something like that. And now you see joule is actually Newton into meter and joule into second, so meter will be cancelled, total will be Newton into second. And if you see, if you divide these things, it will be around 5.2 into 7, this quantity into 10 to the power minus 20 Newton into second. Now this is the moment of an electron if it stay inside the nucleus. If the electron stay anywhere between this anywhere in the diameter of the nucleus, that will be, this is the momentum of the nucleus. Now you see, now we can calculate the energy of the electron. So now if the electron which is coming out of the nucleus, suppose the electron is inside the nucleus and it is coming out from the nucleus, and that electron actually moves with very high velocity, and this velocity is approximately, it is comparable to the velocity of the light. So in that case you can use the relativistic mechanics instead of non-relativistic mechanics. So in relativistic mechanics, the energy, total energy, can be written something like that, and where m0 is the rest mass energy of the electron. Okay, and this quantity, that m0 square c4, is very small than p square c square. So you can neglect this term in comparison to this term. Okay, so now the things will become, because I have neglected the other part, this part I have neglected, so you can put it just simply 0. Now the equation became the energy, the total energy became this much, which is P times C, and P we have already calculated P. This is the value of P. This is the value of P. So you can put it the value of P and C, where C is the velocity of the light. This is the velocity of light. The P is equal to 0.5227 into 10 to the power Newton into second, that 3 into 10 to the power 8 meter per second. So now this thing will be, if you multiply this thing with a 3, that will be this is actually 1 2 8. Okay, this is the quantity, and if you this is 10 to the power minus 12 joule. Okay, Newton into meter, it's joule. The second will be cancel out, so this will be joule. If you convert these things to electron volt, okay, then it will be, then you have to divide a quantity, sorry, 1 joule is actually then you have to divide a quantity, that 1.67 into 10 to the power minus 19. You have to divide, sorry, you have to divide a quantity this much, then the joule will be converted to electron volt. That means 1 electron volt is actually 1.67 into 10 to the power 19 joule, and you can say 1 joule is actually 1 over 1.67 into 1 minus 19 electron volt. Okay, now if you change the total energy, which is actually this much, then quantity will be 1.58 into 10 to the minus 12 divided by 1.67 into 10 to the minus 19 electron volt, which is approximately 10 into 10 to the power 6 electron volt, and we know that 10 to the power 6 electron volt is actually 1 MeV, so you can write approximately it is 10 MeV. Okay, the total energy of the electron, if it is exist according to the uncertainty principle, if the electron stay inside a nucleus, then a minimum energy, it's the minimum energy will be in the order of 10 to 10 MeV. But experimentally it is found from various radioactive element, the electron which is coming out of the atom the electron which is coming out in form of beta ray, it is in the only in the order of 3 to 4 mega electron volt. So that means these electrons is not coming from the nucleus. So that means electron cannot stay inside the nucleus. If electron stay inside the nucleus, its energy will be very high in the order of 10 mega electron volt. But the electron, that means electron cannot stay inside the nucleus. So if it's staying inside the nucleus, its energy should be minimum in the order of 10 MeV. But experimentally it is found that the electron which is coming out in the beta decay, it has energy which is order of only 3 to 4 mega electron volt.